Let me solve another example. In this example, there are 2 points P1 and P2. P1 is equal to x1, y1 and P2 is equal to x2, y2. And we want to prove that D is symmetric on OR scale, or we can say that D is usual metric on OR scale. In the previous questions, we have proved that D is metric on OR. Now we are going to prove that D is metric on OR scale, means usual metric in the plane. When we talk about OR square, then it means that we are talking about a plane. So D is metric on a plane. 2 points are given, P1 and P2, and D will be metric on OR square if it satisfies all the axioms of metric space. You know, there are 4 axioms of metric space: non-negativity, reflexive property, symmetric property and triangle inequality. We will solve all these, we will prove all these properties. If all these properties will be satisfied, then it means that D is symmetric on OR square. So you can see over here that P1 is the point which is equal to x1, y1, and P2 is the point which is equal to x2, y2. And what are these points x1, x2, y1 and y2? These points are any real numbers. So we want to prove that this d into p1, p2, which is defined, is equal to x1 minus x2 square plus y1 minus y2 square. We also called it in calculus distance formula. So this distance formula is metric. We want to prove that this distance formula is metric on OR square. So the first property is non-negative property, and you know that x1 minus x2 square of any number is always positive. Similarly, y1 minus y2 will be positive because square of any positive number is positive. Either it is negative, when we take the square it will be positive. So square of this and square of this is positive. So sum of two positive number is again positive, mean positive number plus positive number, which means that their sum is positive, and the square root of positive number is again positive. It means that whatever this is given, it is positive. So the non-negative property is satisfied over here. So the first property is non-negativity, which means that x1 minus x2 is always positive, and y1 minus y2 square is also positive, and their sum x1 minus x2 square plus y1 minus y2 square is again positive, and x1 minus x2 square plus y1 minus y2 square is again positive, which is equal to distance between P1 and P2 is positive. So the first property has satisfied. The first property satisfy means that distance between these two points is positive. Non-negativity property has been satisfied over here. Now we will jump on the next property, which is reflexive property. The reflexive property is, it is just like distance between P1 and P2 is equal to 0 if and only if P1 is equal to P2. So what does it mean by it? It means that distance between P1 and P2 is equal to 0 means that we will take one side, because here if and only if is using. Whenever we will get if and only if condition anywhere in any questions, then that means that we will prove the both side, means the converse must exist in if and only if conditions. So here we will take this one, distance between P1 P2 is equal to 0, and we will prove that P1 is equal to P2. So first we take distance into P1 and P2 is equal to 0, and this will be if and only if. This will be equal to 0 if the given condition, which is x1 minus x2 square plus y2 minus y1 square is equal to 0. Okay, now if and only if we know that after taking square on both sides we can write it. When we take the square on both sides, square and square root will be cancelled. Square and square root will be cancelled and we will get x1 minus x2 square plus y1 minus y2 square is equal to 0. So from these two terms, there are two terms. The first term is x1 minus x2 square and the second term is y1 minus y2 square. So one of them is 0. Either x1 minus x2 is 0 or y1 minus y2 is equal to 0. So from here we can write that x1 is equal to x2 and from here we can write what is y1 is equal to y2, or simply we can write x1 is equal to x2, y1 is equal to y2, means that x1 comma y1 is equal to x2 comma y2. And we know that when we compare first number with first, means x1 is equal to x2 and y1 is equal to y2. So x1 comma y1 is equal to, this is given that x1 comma y1 is equal to, this is equal to p1 and this is equal to p2. So p1 is equal to p2. Okay, it means that if and only if condition must be used. Okay, if you will write this symbol. When you will write this symbol, then this means that you will not prove the converse. The converse is automatically going with your question. It's okay. So second property has been satisfied, and the third property is symmetric property. The symmetric property is the distance between P1 and P2. The distance between P1 and P2 is given, which is equal to x1 minus x2 plus y1 minus y2. It's okay. So this is x1 minus x2 square plus y1 minus y2 square root. Okay, I will change it, because in square, when we change the number in square, then there will be no effect, because x1 minus x2, if I will write x2 minus x1, it is just like 3 square is positive, and which is 9, and minus 3 square is also positive, which is again 9. It is not minus 9, because in square we can change the term. So I am changing these two terms, just like I am writing x2 minus x1 square plus y2 minus y1 square. Okay, so this means that the distance between P1 comma P2 is equal to x1 minus x2. So it means that this x2 minus x1 is the distance between P2 and P1, is the distance between P2 and P1, which means that the third property, which is triangle inequality, has been satisfied over here. Now we will move to the fourth property, which is triangle inequality. Here triangle inequality, because we are taking 3 points in R square, means we are taking three points in the plane. Okay, that points will be P1, triangle inequality, P1, P2 and P3, and we will discuss about those points for if the points are collinear and if the points are non-collinear. If the points are collinear, then what will be the triangle inequality? Yes, if the points are collinear, then what conditions can exist? If the points are not collinear, then we will see that what condition can exist. Let me solve it. Okay, So the fourth is the triangle inequality. Okay, as we know that let P1 comma P2 and P3 belong to it is just like R square. Okay, R square. Then it means that P1 point is can be written over here is x1 comma y1 and P2 is equal to x2 and y2, and similarly P3 is equal to x3 and y3. Okay, if we check the distance between P1 and P2, it will be just like distance between P1 and P2, and when we will follow this formula, according to this formula, the distance between P1 and P2 is equal to x1 minus x2 square minus x2 square plus y1 minus y2 square. It's okay. So the distance, this is the distance between P1 and P2, and when we will write the distance between P2 and P3, these 2 points, then it means that our formula will be just like x3 minus x1 square plus y3 minus y1 square. Okay, now we write the distance formula. This distance means distance between P1 and P3. So the distance between P1 and P3 is equal to x1 minus x3 square plus y1 minus y3 square. Okay, so since we are going to prove the triangle inequality, and the triangle inequality, there are 2 cases. The first case is when the points are, when all these points means P1, P2 and P3 belong to R square or collinear. Collinear means that they lie on the same line. When the points just like lie on the same line, means P1 and P2 and this is P3, then it means that, what does it mean? The distance between P1 and P2 plus the distance between P2 and P3 is equal to the distance between P1 and P3. Okay, means the distance between these 2 points and the distance between these 2 points is equal to the distance between P1 and P3. It's okay. So in this case, the distance formula will be distance between P1 and P3 is equal to distance between P1 comma P2 plus distance between P2 and P3. Okay, and now we move to the next, the distance between case 2. In this case, we will take these points P1, P2 and P3. The points are non-collinear. Means points are P1, comma P2 and comma P3 belong to R square or non-collinear. When the points are non-collinear, then it means that the point will be just like S. Okay, means if it is P1, P2 and P3, and in any triangle, the distance between 2 sides, the sum of distance of 2 sides is always greater than the third side. Means the distance between P1, the distance between P1 and P2 plus the distance between P2 and P3 will be less than the distance between P1 and P3. Distance between P1 comma P2 plus the distance between P2 plus P2 comma P3 3 is always less than distance between P1 comma P3, sorry, is always less than. Okay, so this is case, this is case 1 and this is case 2. When we will combine these two cases, this case for give the equality symbol and this case give the inequality symbols. When we will combine these two results, then this means that what we will get, so combining these two cases, it means that distance between P1 comma P3 is less than or equal to distance between P1 P2 plus distance between P2 and P3. So it means that the third property has satisfied over here, fourth property, sorry, which is in triangle inequality. So all the properties has been satisfied, which means that D is symmetric on R square.